Upthrust or buoyancy, part 1. How do you lift an object? Obviously, by applying a force required to lift it in an upward direction. This force is equal to the weight of the object. How would the weight of this object appear lighter? Weight of this object would appear lighter if someone else also applies force in the upward direction. Now let us do an experiment. It is a common experience that objects weigh lighter in water. For this, let us take a spring balance and suspend an object on it. Let us weigh it in air. Now suspend this object in water. We will observe that it weighs less in water. It is as if something is pushing the object upwards when it is immersed in water. Let us repeat this experiment using a physical balance. Two identical objects are placed on either side of a physical balance. Since they are identical, the physical balance seems balanced. Now, one of the object is immersed in water. Immediately, the physical balance tilts in the favor of the other object. The object which is immersed in water appears lighter as if something is applying force on it. In both these experiments, we saw that the objects that are immersed in liquid appear lighter. Obviously, when immersed in water, something else is also applying force in the upward direction. The tendency of fluids to exert an upward force on a body immersed partially or wholly in them is called buoyancy, and the force is called upthrust or buoyant force. Remember, when we say fluids, we mean liquids and gases both. It is this upward push acting on the immersed body that makes it appear lighter. Let us do an experiment. A container is filled with water and a cylindrical object is placed in it. Let us see the various pressures acting on this cylindrical container. The pressures acting on the lateral surfaces of the body are equal and balance each other. This is because at the same depth, pressure is equal. Pressure P1 acts on the upper surface in downward direction. Pressure P2 acts on the lower surface in upward direction. Let h be the height of the object. this is the height of the object equal to h. Let h1 be the height of the liquid column above the upper surface of the body. So this is the height of the liquid column above the upper surface of the body, which is equal to h1. Let h2 be the height of the liquid column above the lower surface of the body. So this is the lower surface and this is the height of liquid column. This is the height of liquid column above the lower surface of the body, h2. Let A be the surface area on which the pressure acts. So this is the surface area on which the pressure is acting. The upper surface area and the lower surface area. Now we know pressure is equal to height of liquid column into density of liquid into acceleration due to gravity. Now we know that pressure is equal to force upon area. Hence, we can find out force if pressure and area are known. Now here F1, that is the force acting on the upper surface, would be pressure on the upper surface into area of the upper surface. So H1 dg into A. Pressure acting on the lower surface P2 is equal to H2 dg. So we can find out the force acting on the lower surface, which is equal to pressure into area, that is H2 dg into A. Now we have got the force acting on the upper surface area, we have got the force acting on the lower surface area. F2 would be greater than F1 because height of liquid column above the lower surface area is more than height of liquid column above the upper surface area. The resultant upward force would be F2 minus F1. Let us substitute the values by taking A, D, G common. So we have taken A, D, G common. We get H2 minus H1. And H2 minus H1 would be the height of the object. So we have area of the object into height of the object into D into G. Now area into height is volume. So the resultant upward force is equal to V into D into G. Thus, mathematically, upthrust or buoyant force is equal to VdG. Kindly pay attention to what V, D and G represent. V is the volume of solid immersed. This is equal to the liquid displaced on immersing the solid. D is the density of liquid in which solid is immersed. It does not represent the density of solid. Small g is acceleration due to gravity. Thank you.